All right. Hello and welcome to Group 8's final presentation. Here in the bottom right, you can see our completed robot. We'll go into details over this, and later in the presentation, we'll actually see a view of it running the course compared to our competitor team doing it. This group consisted of me, Casey Strong, Corryn Sams, John Chandler, Madison Godlsmith, Timo Leppanen, and Trey Wright. And unfortunately, Trey is not able to join us today. He is sick right now, and so he will not be part of this presentation.
For controlling the robot, 3 line sensors were used. The line sensors function by detecting the color below them and returning a voltage signal. Used 3 of them so that 2 could always determine if the line was becoming left or right of the sensor or if it is staying on track. Three different actuators were used, 2 different types. One was a servo motor. The servo was used so we could carefully control the positioning of the forks on the front of the robot, and that was to make it easier for reliability for picking up the GameCube and setting it back down. The two other motors we used were geared DC motors. Those were picked because they could turn the wheels, and we can control them with an H bridge to make it easier for steering the vehicle.
For performance of the basic computer interfacing and measurement, we use an Arduino IDE programming language in the language of C. The servo was controlled using the Servo H library. This was the only library that we had to use for this code. We didn't end up using math or anything else for this code. The gear motors were controlled using the H bridge for the direction of the PWM output for speed. So we use the H bridge to really control just about everything in our robot. The line sensors were read using the analog input and filtered through the moving average filter. So we made sure to have our 3 sensors and we read them through our program to be able to do, to run the robot across the line as it should be. Applying the basics of signal conditioning, the signal from the line sensor can be rough from external variables. So we did actually end up running into a couple errors when we did try to originally run this, as there were some issues when trying to run it on a wooden surface with a black line, as there was interference with the patterns and the textures and the colors. So we found that the best way to run this was on a white board with a black line, so that way we could get the most amount of variance. The variables include source. So that's kind of like our variables and our sources of errors. The signal can be smoothed using a moving average. The moving average is a digital filter that takes the last 4 values from the sensor, averages them, and gives the average as the voltage from the line sensor. So that helped us be able to correctly do this.
And then a little bit more on those sensors. So even with all of the even with the moving average filter, it is important to understand what's going on inside that filter. So we use a little bit of statistics analysis to really make sure that we had a good threshold value to use for those sensors to tell between the black and the white. This is really important because that's the entire premise of the line following. So without this work, we would not have been able to properly follow the line or complete this task.
So as we started the project, designing our competition, we had to keep in mind the implications of what we were designing. So we did a little bit of research on ways that this type of robot was already being used and how it could, in the future, affect our society and the world as a whole. But in the end, what we decided on for our competition was a line following race, with picking up an object on one side of the board, turning around and setting it back down on the other side. So we broke down all of those steps so they were a little bit simpler, and then we could apply them to the specific components that we had decided on. So like John had talked about, we used our line sensors to detect the path, and then the gear motors to be able to adjust and make sure that it was following the line correctly, and then our servo motor to pick up and hold the object and set it back down.
So as you will see here, we have two videos. The one on the left is the competing team. The one on the right is our video. Unfortunately, the competing team was slightly faster than us, so we did lose. However, we did both complete the robot and get it to complete the challenge. So as you can see here, the robot is following the curved path, and it stops, picks up the object, then it turns around, follows the curvy path back, and then once it gets back, it will set down the object. As you'll be able to see over here, this competitor's team doing it. The robot, they managed to get the robot to follow the line quite a bit faster than we did, but yeah.
This may have been done also partly in use due to the extra sensors, because they did use 5 sensors for the robot, where we used 3, so they had a ability to use more sensors to more precisely follow that line. So it's a thought for in the future.
So there was a few main considerations that we were looking at within the teamwork. One of the main things that held kind of our project together was having regular meetings and having a group chat that everyone was a part of to communicate progress and communicate what needs done. And another thing that kind of helped a lot was staying up to date on the report and doing the report as we're doing the project, so we didn't have a big old hump at the end that we'd have to overcome. And each of us were given specific tasks, but especially with the meetings and the group chat, we were able to all help each other out, and there was a lot of collaboration with that. And there's a few issues that arose. One of the main things was I am not at the School of Mines currently, and I'm doing online school, so not everyone can meet in person. And we had a Zoom call during the in-person meetings for the people that weren't able to meet. And for everyone else, the scheduling was done with a spreadsheet, so everyone could put their available times, so we could find a time that was available for everyone. And all of our report and our work were online, so all of us could work on it from wherever we were and at whatever times.
And with that, thank you for watching our presentation. Please let us know if you have any questions.